Yes. The subject name is non-conventional source of energy. And with a code of 18ME651, and the subject is an open elective for all the branches. And first thing, we have to know why we have to study this subject. That is what preface of this subject is. So it is well known fact that uh, a source of fossil fuels, a source of fossil fuels in the worlds are depleting. It is a fact. The source of fossil fuels are depleting very fast. And by the turn of this century, the man will have increasingly depend upon a renewable source of energy. A renewable means non-conventional, a source of energy. For the development of countries, means ours is the a developing country like India. It's a large scale demand of heat energy for meeting day to day domestics, means day to day life. In our day life, we need these kind of sources, and for the domestic purpose, for the institutional purpose, or for the industrial requirement, can be met by utilizing the solar energy. It's a one option, or biogas, or PV cells, or wind energy, or geothermal energy. Like this, there are so many types of energies for the non-conventional source of energies. And these non-conventional source of energies, one of the area of emerging technologies which have higher priority with a reference to the national needs. It is directly depends on the national needs. The energy is an important input in all sorts of any country's economy. The standards of living of a given country can be directed related to the per capita energy consumption. Means the developing countries or a developed countries, it is directly depends on energy, is directly depends on standards of living and energy consumptions. The energy needs of a developing country like India, it's increasingly significantly we depend on the non-conventional energy sources. Hence, absolutely the necessary plan for critical energy input so that the country development is not hampered, it is not disturbed. So we can plan in such a way that we have to utilize all type of energies with effectively without wasting. So this is what we have to, why we have to study this subject. Okay. So based on this, university made this subject as an open elective for all the branches. Okay. And of course, this subject is a core subject for the mechanical engineers. But apart from the mechanical engineers, others is the open elective. Okay. So based on these things, university frame a one syllabus. Okay. And in that syllabus, we have a 5 modules: module 1, module 2, module 3, module 4, and module 5. And first, the course objective means the important thing is the objective of course. University made some of the objectives. That is, the first objective is to introduce the concept of solar energy, its radiation, collection, storage, and application. The first objective of this subject is to introduce the concept of solar energy. Means you have to know what is meant by solar energy, how we have to collect, how we have to store, and how we have to use for different applications. That is the first objective. And the second objective is to introduce the concept and applications of wind energy, biomass energy, geothermal energy, ocean energy, and other alternative energy sources. Means these are all a non-conventional energy sources, and we have to have some awareness, some idea on these type of energies. That is what the second objective. And third objective is to explore society present needs and future energy demands. And the fourth objective is to examine energy source systems including fossil fuels and nuclear energy. Then focus on the alternative renewable energy sources like what we discussed in the above. And the last objective is to get exposed to the energy conversion method, how we are going to convert one energy form to another energy form. So these are the main course objectives. By having these course objectives, the university set a one syllabus. The first module, like the module wise they set the syllabus, and the first module is it is completely uh, introduction of the energies, a source of energies, what are different types of energies, and what are the renewable and non-renewable energies, and what are the non-conventional energies, different types of non-conventional energies. That is what we are going to discuss. That is the first introduction. And in the first, of course, it's just like a other subject. Here also we have the each module will frame by 2 questions. Okay, and one question you have to compulsory, you have to attend the one question, and one question is for 20 marks. Okay, and the first module I told it is an introduction, and later come to the solar radiation. In the first module only, first we have the introduction about the all source of energies, then we come to the solar radiation, particularly on the solar energy. What is meant by terrestrial energy, extraterrestrial energy, what is solar constant, those things we are going to study. And in the same module, the measurement of solar radiation, how we are going to measure the solar radiations with the help of devices called pyrometer, sliding ring pyrolimeter, sunshine recorder. So these are the different equipments, devices we are using to study or measure the radiations. So this completes the first module. Okay, and the second module is again it is related to the solar energy. That is what solar radiation geometry means. What is the latitude, what is the declination angle, what is the surface azimuth angle. So how the solar energy is projected on the surfaces, how it is inclined, and how we get best and maximum solar radiations. That is what we are going to study, and some of the equations what we are using. Okay, and based on these equations we are going to solve some of the problems. And next in that same radiation flux on the tilted surface. Okay, and here how the tilted surface, the radiation flux is there, what is the beam, what is the diffuse, what is the reflected radiations, and expression for flux and tilted surfaces. But there is no derivations, only equations what we are going to study. Here there is no derivations, and based on the equations we are going to solve some of the problems. And in the same thing, we are going to study the solar thermal conversion. How we are going to convert one form of energy into another form. Thermal conversions. Okay, thermal collector, flat plate collector. That is what you already know that. So solar heater, water heater. In your home, you are using solar water heater. So solar energy converted into heat energy. The water will get heated. So like this, we are going to study some of the different types of conversions. So that is what the second module. Again here there is a 2 questions. And in the third module, it is purely performance analysis of liquid flat plate collector. It's a one flat plate collector, in that the solar radiations are collected. So here the performance analysis. What is the geometry? What is the selective surfaces? What is the basic energy, balance equation, stagnation temperature, transmittivity? All things we are going to study in this module. And lastly, one of the important concept like photovoltaic conversion. Photovoltaic conversion is a small device which converts solar energy into electric energy. That is what we are going to description, principle, and working characteristics we are going to discuss. This is what the first module, second module, third module. It is purely based on the solar energy. And in the fourth module, it's another type of non-conventional energy source. Like after the solar energy, we go with the wind energy. So in the fourth module, it covers wind energy, the properties of wind, availability of the wind energy in India, and what is the velocity, and what are the wind power and wind machines, types of wind machines, and its characteristics, horizontal, vertical, windmills. And based on this, we are using some equations, and those equations we are going to solve some problems. This is wind energy. And in the same module, one more non-conventional energy is tidal power and ocean thermal energy. Tidal power means it is in the oceans, there is a tides, waves are there. By using that waves and tides, we are going to convert one form of energy into another form. That is with the help of some devices, fundamental characteristics. That is what we are going to study. And ocean thermal energy means in the ocean, there is a difference in the temperature. In the top layer and in the bottom layer, there is a difference in the temperature. And by using that difference in the temperature, we are going to extract the energy and convert to the electric energy. That is, we are going to study in ocean thermal energy, how we are going to convert and how we are going to get energy. And this is what in the fourth module. And in the last module, fifth module, again, there is another source of energy. It's like geothermal energy, means in the earth crust, there is a geothermal energy, and energy from the biomass, bio waste, from the agricultural, from the kitchen, we have some waste, bio waste. By using that bio waste, we are going to convert the energies. We are going to get the energy. And lastly, hydrogen energy. Okay, so geothermal and biomass and hydrogen energy. This covers the fifth module. So this is what total 5 modules, okay, and each module having in 2 questions. And first module, second module, third module related to the solar energy, and the fourth and fifth module related to the another types of renewable energies. Okay. And after these 5 modules, there is a course outcome. Means after studying this subject, the student able to aware of the some of the concepts. That is what is course outcome. CO. We call it as a CO. CO1, CO2, CO3, CO4, CO5, CO6, CO7. There are the 7 COs are there. Okay. The first is describe the environmental aspects in non-conventional energy sources in comparison with the various conventional energy sources with prospects of limitations. Means after studying this subject, the student can able to attain these COs, course outcome. Okay. And come to the textbook. There are so many textbooks referred by the university. The first textbook is B.H. Khan, Non-Conventional Energy Sources. Okay, it is available in our library. Next, G.D. Roy. It is also one of the a good book. It is also available in our library. You can refer. Or Sukatme is also one of the famous book for this solar energy. You can refer. And Bansal is there. So these are some standard books they referred. Okay. Apart from this, I am going to give the notes. Okay, the notes made by according to the VTU syllabus. Okay, you can refer either my notes or you can directly refer to the textbook. And this subject is for totally 100 marks and total 10 questions. In each module you will get 2 questions and 1 you have to compulsory attend. So total 5 modules, 5 questions into 20, you will get 100 marks. See the first slide, you can observe that it's a non-conventional energy sources. In the first slide, there are some pictures which describes a non-conventional or renewable energy sources. So these are the devices which converts a one form of energy into another usable form. Okay, so here you can observe solar panels is there, windmill is there. Okay, here some nuclear power plant is there, hydrogen plant is there. Okay, windmill. So these are all plants, or here the steam engine plant is there. Okay, so these are all plants which used to convert one form of energy into another usable form. So first, you already know that what is meant by energy. The first basic definition is what is energy. So this subject is purely depends on energy. If you go with the first module, second module, third module, fourth or fifth, there is you will get an energies, a plenty of energies, and which convert one form to another form. The total subject is related to energy. And you know that you know why we have to study this subject means we already in the preface we discussed why you have to study. Means in short, I will tell you why you have to study. Means for every Means without energy, we cannot do anything. Without energy, we cannot do anything. Without energy, I cannot talk. Without energy, you cannot listen, or you cannot write, or you cannot move. For every emotion, we need a energy. For every action, we need a energy. Is it correct? Energy is just like a source. So energy is just like a source. From that, we can do anything. We can do any action. Is it correct? For us, we get energy from, by heating, we get the energy. Is it correct? By eating the food, we get energy. That food is converted into whatever the energy required in our body. So that from that food, we can walk, we can talk. Is it correct? We can move from one place to another place. We can hold, we can lift. So for every action, we need energy. Not only human beings, for animals, okay, they also need the energies. Okay, for come to the construction. Okay, you people are belongs to the civil. Okay, so for construction of any buildings, okay, you need energies. For driving any machines, so for driving car, driving bike, you need a energy. So in that chemical energy, that is what petrol, what or diesel you are using, that converted into another useful form. Or for any construction, you need a devices like JCB. You need JCB, or you need some of the machines, cement mixture machines. Is it correct? So you need different types of machines. To drive those machines, again you need energy. Okay, if you people belongs to the electrical, yes, for the transformer, for motors, for pump, for everything, you need energy. Without energy, those machines cannot run, cannot drive. Is it correct? And again, if you are people from the computer science, yes, of course, computer science people also need a energy, because yes, the computers, the laptops, whatever the softwares you are going to develop or execute, okay, for that you need a devices like laptop, or whatever your mobiles or system. And for the system, if you want to switch on the system, you need energy, electrical energy. Yes, without energy, you cannot switch on your phone, your laptop, your system. Again, you need energy. If you are a electronic students also, you need a energy to operate the microcontroller, microprocessor, or different types of devices. Again, you need energy. So energy is compulsory and need for all the branches. That's why the university made this subject just to create awareness. What are the non-renewable energies and how they are depleting day by day? Okay, and what are the alternatives to replace those non-renewable energies, and what are those renewable energies, and how we can convert one form to another form? That is what the awareness, and how preciously we have to use the energies. The saving, energy saving is more important than energy generation. Always you have to keep in mind, you have to save the energy. If you save the energy means you can reduce the energy generation. Okay. And one more thing, you just remember, energy is neither created nor be destroyed. The energy cannot be created or cannot be destroyed. The energy only we can convert from one form to another form. The energy we can convert from one form to another form. We cannot create the energy, or we cannot destroy the energy. Okay. The first, where this energy, the word is come from means, the energy is a word derived from breathe. The energy is a word derived from breathe. This energy means in work or work content. In work or work content. The energy can be defined. We generally, energy can be defined as ability to work. We can define this energy as a ability to work, or the work output depends on the energy input. If you provide the input, then only you will get the output. Means for output, we need an input. That input is energy. Output is work. So energy can be defined as ability to do the work. If you want to do any work, we need a energy. So with the energy, with the ability, we can do the work. The energy is measured. Means what is this unit? SI unit is, the SI unit of energy is joules, which is same as work. Okay. It's the most energy is the most basic infrastructure input required for economic growth and development of country. It may be the individual person, or it is maybe the industrial growth, or maybe the country growth. It is directly depends on this energy. It's a basic infrastructure. And this energy is all around us. We can hear energy as a sound. Means if you want to produce any sound, it need energy. Means that energy is connoted as a sound. We can hear the sound, means we can hear the energy sound by blasting the crackers. If you blast the crackers, it will make a sound. That sound is energy. We can see the energy as a light. Of course, a light is a form of energy, is a source of energy. Okay. So while crackers, if you blast the crackers, you'll get the sound as well as you'll get the light. Or in the rainy season, we can observe the thunder. Okay, it's a form of sound, and lightning, you get the light. It is also a huge form of energy. And we can feel as a wind. If the wind is flow from one side to another side, means there is a energy. Without energy, wind cannot move. If the wind is flowing, means there is a energy is there. That energy will flow wind from one side to another. We can feel the energy. We can see the energy. We can feel the energy, and we can hear the energy. Okay. And this systematic study of various form of energy, the energy transformation is called energy science. And while fossil fuels will be the main fuels for thermal energy, means so far we drastically or we majorly depends on the fossil fuels. But the fossil fuels are day by day they are depleting, they are exhausting. Okay, one fine day, after 5 years or after 10 years, there is no petrol, there is no diesel, there is no charcoal. At that time, we cannot go with the alternative energies. Now only we have the awareness, and we have the plan, and we have a proper working devices, so that those devices effectively can replace this petrol, this diesel, or this coal. Means at that time we cannot feel empty. So for that we are going to study this subject. There are 5 main forms of energy. There are 5 main forms of energy. The first one is heat energy. Second one is chemical energy, and electromagnetic energy, nuclear energy, and mechanical energy. Okay, so these are the main forms of energy. So heat energy. So heat energy means while cooking. So cooking means or in your IC engines. Okay, so that heat what we are getting, that is an heat energy. Or you in cooking. Okay, if you want to boil the water, so there is an heat energy. Means that water slowly gain the energy, means slowly rise the temperature, and there is a conduction taking place. After the conduction, there is a convection taking place. After the convection, there is a radiation taking place. This is what the heat energy: conduction, convection, and radiation. Okay. And the second type of energy is chemical energy. Chemical energy means petrol, diesel. These are all chemicals. Okay. So there is a chemical energy, and because of the chemical reactions, it will forms or it will give the energies. Okay. Exothermic reactions means it will produces the energies. Okay. Petrol, diesel, okay, kerosene. These are all chemicals. By burning these chemicals, there is a chemical reaction taking place, and by the chemical reactions, it will produce the energy. That is what chemical energy. The energy is stored in chemical. Electromagnetic means that is what electrical and magnetic field. It is also a type of energies. With the help of that is semiconductors or magnetic poles, positive and negative, we are going to store the energy or we can utilize the energy by using electromagnetic flux. And next is nuclear energy. There is a fission and fusion. There is a two process. We already know that one is combining and other one is splitting. By splitting or by combining uranium or any other elements, we get a lot of energies. That energy is also a nuclear energy that we can use for any useful form. And lastly is mechanical energy. Mechanical means by moving IC engines or windmills, okay, or in your turbines. So these are all mechanical devices, mechanical energy, and that is stored in movements, okay, or in the devices. Mechanical energy. That mechanical energy we can convert into any other forms. Mechanical energy into electrical energy or mechanical energy into any other useful energies by driving the devices. Okay, steam engine is the one best example. IC engine is the example. Okay, these are all some mechanical energies. So these are the five important forms of energy. Uh, Next slide. So all forms of energy can be converted into other forms. Means, and I already told that energy cannot be created nor be destroyed. Okay, only thing is we can convert or we can transfer from one form to another form. Here, the sun energy through the solar cells, we can convert it into directly electric energy. Or green plants, that is what the plants, that green plants, because of the photosynthesis, they produce the energies. That stored energy, we can convert it, electromagnetic energy, into starch or sugar. That is what chemical energy. In electric motors, electromagnetic energy converted into mechanical energy. In batteries, the stored energy is chemical energy, which can be converted into electromagnetic energy or mechanical energy of the waterfall. That is what in the hydro power plant can convert it into electric energy with the help of generators. So these are all what a general conversion from one form to another form. That is by heat to electromagnetic or heat to chemical or heat to mechanical like this, or mechanical to electrical like this, we can convert any form. Okay, and all forms of energy can be either in the two state, means whatever the energy is there, it is either in the two states. One is potential energy and kinetic energy. Potential energy and kinetic energy. There are two important forms of energy. Either energy in the form of potential energy or kinetic energy. Okay, there are five forms, but energy states are only two states. Either it is in the potential energy or it is in the kinetic energy. First, what is meant by this kinetic energy? The kinetic energy means it is with the energy with respect to the motion. The energy with respect to the motion is called kinetic energy. Okay, the energy with respect to the motion. What we are walking, or driving the car, or driving the bike, or driving any machines, or your fan. So fan, in the fan what happens? The electric energy is converted into mechanical energy. Okay, but in that there is a motion. The mass into velocity. That mass into velocity, it gives kinetic energy. Okay, it is the first state of energy. Second, potential energy. Potential energy means it is a stored energy. Sorry, the energy is stored. For the best example is the water is stored in the dam. In the dam, the water is stored. In that, it is the energy is in the form of potential energy. Then from dam to turbines, the water slowly moving through the pipelines. Okay, that is kinetic energy. In that, kinetic energy converted into electric energy. Or chemical is the best example for potential. Again, there is a chemical, it's in the fuel. In the fuel, there is a lot of energy stored. Okay, or in the nuclear power plant, there is a lot of energy stored in the atoms. Or if you take an example of human beings, the energy is stored in the food. If you eat the food, you will get the energy. Okay. So you can take some more examples like stretching the rubber band. So if you take a rubber band, the energy is stored. If you stretch, yes, the energy is in the form of stretching. Okay. And if you release that, again it will regain. Okay. That is elastic energy. It is in the elastic energy. So again, you can take any form of energies. Arrow, you can take from the bow, you can arrow is the best example, okay, by pulling that arrow. And once you release, it will move with a very high velocity, means potential energy into the kinetic energy. So these are some examples. Lifting any weights or bricks again into the air. So stored energy into the kinetic energy. So only the energy is stored either in the form of kinetic energy or in the form of potential energy. Okay.